Hello there. Today we are going to learn how to find secant lengths in circles, which is the last part of Target 3. The segments of chords theorem. If two chords intersect inside of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So let's break down this theorem. It says that the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So we're going to be multiplying the individual segments of these chords. So let's see how this will be set up. So we have two chords inside of this circle. We have the chord LM and we have the chord JK. So those are the chords, the total segment lengths that we're going to be solving for. But in order to do that, we need to break it up into individual segments of each chord. Now the two chords intersect at point N, so that's going to create our two segments per each chord. So we're going to start with chord LM, which its first part is LN. So LN times NM is equal to Jn times Nk. Let's fill in what each of these segments are according to the picture. Lm is x plus 3 times Nm, which is x plus 1, is equal to Jn, which is x plus 5, times Nk, which is x. Okay, so now moving forward, we're going to have to do some distributing, and in order to distribute x plus 3 times x plus 1, we're going to use the box method. So make sure you leave enough space to complete this whole problem when you're writing small. I'm going to do the box method off to the side, so I'm going to draw my box and then put my two factors on the outside. I have x plus 3 and x plus 1. Now I'm going to multiply each dimension of the box. So x times x will be x squared, 3 times x is 3x, 1 times x is 1x, and 3 times 1 is 3. So I'm going to take the inside of this box and write it underneath where I needed to distribute. So I take each part of the box, x squared plus 3x plus 1x plus 3, and replace it where we had the x plus 3 times x plus 1. So everything from the box method is equal to the right side of our equation, which is x plus 5 times x. So we'll need to distribute that x to both parts. X times x will be x squared, and x times 5 will be 5x. Now we need to combine some like terms. On the left side of the equation, I can combine 3x and 1x to be 4x, and the right side just stays the same for now. Now we can start solving. So I'm going to subtract my x squared, move it to the left-hand side, and conveniently they actually cancel out. So I'm just left with 4x plus 3 equals 5x. Now I'm going to subtract 4x from the left side and then the right side, and I'm left with 3 equals 1x, so x is equal to 3. Well, we're not quite done because we needed to solve for the entire segment length. So let's start with ML. ML is equal to LN plus NM. So LN is x plus 3 and NM is x plus 1. So wherever I have an x, I'm now going to plug in a 3 because that's what we solved for. So ML is equal to 6 plus 4, which is 10. ML is 10. Now let's plug in 3 into x's to solve for JK. JK is equal to Jn plus Nk. Jn is x plus 5, and Nk is x. So now we plug in 3 for the x's. 3 plus 5 plus 3. Well, 3 plus 5 is 8 plus 3, which JK will be 11. So now we're done. We've solved for both segment lengths, secant lengths, chord lengths. chord lengths, I'm sorry. Now moving on to the segments of secants theorem. If two secants share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equal the product of the lengths of the other secant segment and its external segment. So in this picture, we're going to be solving for the value of x. So how we use this formula is we take the whole entire segment and multiply it by the external segment. So our first whole entire segment is PR. So PR is the whole segment being multiplied by the external part of the secant PR, which is QR. And that's equal to the whole entire other secant, which is TR, multiplied by its external segment, which is SR. So the whole times the outside part equals the whole of the other secant times the outside part. So let's plug in what's given to us. Well, PR, the whole segment, is 4 plus 6, which will be 10. So 10 times the external segment, QR, which is 6, is equal to the whole segment length of TR, which is x and 5, which added together is x plus 5, times the external part, which is 5. So 10 times 6 equals 60, and we're going to have to distribute the 5 on the right-hand side to be 5x plus 25. Now I can solve. Subtract 25 from both sides. 60 minus 25 is 35, which is equal to 5x. Divide by 5, and I'm left with x is 7. And we're all done. In this example, we didn't need to solve for the actual secant lengths, so just solving for x gives us our solution. So that's all for this video, and make sure that you come in with lots of questions tomorrow and work hard.